Hello guys, I am Vipin Kumar and today we discuss the number system, which is the first chapter of ninth class mathematics book. Introduction of number system. Firstly, we talk about what is number. Number is an arithmetic value represent a particular quantity. The various type of numbers are natural number, whole number, integer, rational numbers, irrational number, real number, etc. So what are natural number? Natural number, it is represented by the capital N. Natural number are positive number, that is 1, 2, 3, and so on. Whole numbers, what are whole number? Whole number are represented by the capital W. They include all the natural numbers and including 0. They have all the natural number and including 0, that is 0, 1, 2, 3, and so on. The whole numbers do not include any fraction, negative number, or decimals. So now we come to integer. What is integer? Integers are just like whole number, but they also include negative numbers. They are denoted by capital Z. For example, -3, -2, -1, 0, 1, 2, 3, and so on. So now we come to rational number. What are rational numbers? Rational number are notified by R. That if a number can be written in the form of P by Q, where P and Q are integer and Q is not equal to 0, then it will be a rational number. So it means any number which is written in the form of P by Q and P and Q are integers, then and Q is not equal to 0, then it will be a rational number. Like 1 by 2, 1 by 3, 4 by 5. These all are rational numbers. 4 by 1. So now we come to irrational number. What are irrational numbers? Any number that cannot be expressed in the form of P by Q, where P and Q are integer and Q is not equal to 0, is an irrational number. For example, under root 2, that is 1.010024563 and so on. Sorry for the disturbance. Where we are in the on the irrational numbers. So I give the example of irrational number, which is under root 2, and another example of irrational number is pi. Another example is 1.010010001 and so on. So now we come to real number. What are real number? Any number which can be represented on the number line is a real number. It is represented as capital R. It includes both rational and irrational numbers. Every point on the number line represents an unique real number. So basically, any number which is represented on real line, that is real number. What are irrational numbers? Or representation of irrational number on number line. So let under root x be a irrational number. To represent it on the number line, we will follow the following step. Take any point A, draw a line AB. Take any point A, take any point A, draw a line AB, extend it to the C. Be 1 unit. Find out the midpoint. Find out the midpoint of it and name it O. With O and center as the center, draw a semicircle. Draw a semicircle with radius OC. Draw a straight line from B is perpendicular to AC. That is intersect the semicircle at point D. Length of BD is equal to under root x. With BD as the radius and origin as the center, cut the positive side of the number line to get under root x. Define the irrational number. Identify identities of irrational numbers. Operation on rational and irrational number. Arithmetic operation between rational and irrational. So if we multiply in a number which is p by q by an irrational number like under root 2, then we get a irrational number which is p by q under root 2. And if we multiply an irrational number like under root 3 by under root 3, then we get a rational number which is 3. And if we multiply irrational like under root 3 into under root 2, then we get a irrational number. So there are some examples also. Identities for irrational numbers. There are some identities for irrational numbers. If a and b are real number, then if a and b are real number, so under root ab is equal to under root a into under root b. So these all are the identities for the irrational numbers. Rationalization. What is rationalization? Rationalization is a converting an irrational number into a rational number. Suppose if we have to rationalize a under root 1 under root a, 1 by under root a, so we have to find the conjugate of it. Its conjugate is 1 by under root a. So we find, if we multiply this, its answer is 1 by a, because under root a is multiplied by under root a, then under root a square is equal to a. So second example is 1 by under root a plus b. So we have to find its conjugate. So its conjugate is under root a plus b. Its conjugate is 1 by under root a minus b, because we find its conjugate, the sign of the second digit, that is b, the sign of the second digit will be changed. If it's minus, then it will be converted to plus. If it's plus, then it will become converted to minus. And so now multiply it, and the answer will be a minus b, 1 by a minus b square. So law of exponential for real numbers. So exponents law for real number are some exponent law for if a, b, m and n are real number, then a raised to the power m and into a raised to the power n, then it will be am plus n, a raised to the power m plus n. If a raised to the power m bracket n, then it will be a raised to the power m into n. If a raised to the power m by a raised to the power n is equal to m a raised to the power m minus n. Okay, so exponential representation of irrational number. What is the exponential representation of the real number? Irrational number. If a is greater than 0 and n is a positive integer, then nth root a is equal to a raised to the power 1 by n. Let us say let a is greater than 0 be a real number and p and q be rational number, then this all a raised to the power p into a raised to the power q is equal to a raised to the power. These all are the above identities, but only the m and n are replaced by p and q. Decimal representation of rational number. What is the decimal representation of rational number? The decimal explanation of rational expression of rational number and irrational numbers. So, the decimal expansion of rational is either terminating or non-terminating and recurring. So, what is terminating? Like there are terms like 1 by 2. It will be 0.5. It is a terminating. And like 1 by 3, and like 1 by 3 it is non-terminating. It's 0.333, and this 3 is occurring many times, then it will be reoccurring and non-terminating. And decimal expansion of any rational number is not terminating or non-recurring. So the decimal expansion of irrational number is neither terminating and nor recurring, like under root 2, which will be a 1.41421356 and so on, like pi 3 is equal to 3.1458 and so on. Okay, expressing decimal as rational numbers. Case 1, terminating decimals. Example 0.625. Let x will be 0.625. If the number of digit after the decimal point is y, then multiply and divide the number by 10y. So the x is equal to 0.625. It will be multiplied by 1000 by 1000, 1000 by 1000, then it will be 625 divided by 1000. Then reduce the obtaining fraction to its simplest form. Then we reduce this to the simplest form, 625 by 1000 and cut and 5 8. Okay, so the x is equal to 5 by 8. Reducing decimal. If the number is non-terminating and recurring, then we will follow the following step to convert it into a rational number. Example: let x is equal to 1.04242 bar. So step 2, multiply the first equation with 10y, where y is the number of digits that are. So this is the first equation, and it multiplied by 10y. What is 10y? 10y is the number of digits that are reoccurring. So there are two number of digits which are reoccurring, so it will be divided by 100. Thus 100x is equal to 104.242. So step 3, this is the equation 2. So step 3, equation 1 from equation 2, subtract equation 1 from equation 2. So we subtract the equation 1 from equation 2, which is the answer is 99. X is equal to 103.2. Then x will be the 103.2 by 99 is equal to, we reduce the decimal, then it will be 1032 by 990. Then we reduce and convert it into the simplest form. So 990, so 172,165. So it will be x will be the 172 by 165. Thank you guys, have a nice day. The end of the video is here. If you like the video, please subscribe to my channel and press the bell icon for more notification. Thank you, bye bye, and have a nice day.